In last class, what we have done, we have just see what is the property of inertial frame, what is definition of frame, and how we can use the Galilean transformation to understand the speed or velocity between two frame and one particle with respect to another frame. So this is all about our use of Galilean transformation. And Galilean transformation is very nice transformation. Why it is very nice transformation? Because it's a two-way transformation. Means if you have Galilean transformation, you have inverse Galilean transformation. Just by, if you can remember in last class, we have, this is my S frame and this is my S dash frame, and S dash frame is moving with respect to S. And if this particle have speed ux dash, ui dash, uj dash with respect to S dash frame, so I am using this notation, and same time the same particle P has speed ux, ui, uz with respect to S, then we have ux is equal to ux dash plus v, and same time we can also write ux dash is equal to nothing but ux minus v. That means if we have independent variable at ux dash and v, we have dependent variable ux, and same time if we have independent variable as ux and v, then same time we can get ux dash, only we have to just change the sign of this particular v. So we can write this particular thing something like this. And we have also algorithm. What is this algorithm? This is very interesting. Velocity of particle with respect to s is equal to velocity of particle with respect to s dash plus velocity of s dash with respect to s. And when we are changing s to s dash, only we have to change this particular sign, isn't it? And we have to write this particular thing. Suppose we are writing velocity of particle with respect to s dash is equal to velocity of particle with respect to s plus velocity of s with respect to s dash, and we have relationship that velocity of s with respect to s dash is same thing that minus velocity of s dash with respect to s. So this is a wonderful transformation. By the way, we can see that we have the transformation in a position also, something like x is equal to x dash plus vt, and this transformation is linear in nature. Why I am saying it is linear in nature? Because we have x dash have same power and they have very nicely linear information, linear relationship. Why it is linear relationship? Because we are working with the inertial frame. So why we have this information? In an inertial frame, when you have constant velocity, then obviously the relationship between x and t or x and x dash will be obviously linear. So this is a linear transformation. So if this is linear transformation, obviously this is simple, very nice and simple. This is not complex. Okay, this is very simple transformation. But real problem with the Galilean transformation is that when we are going to change any of this speed or velocity of v with near about speed of light, then obviously it doesn't work, because we have one particular experiment, and that experiment is identified as Michelson-Morley experiment. Michelson-Morley experiment. What is Michelson-Morley experiment? It just conclude that speed of light is invariant speed of light is invariant under any inertial frame. Speed of light is invariant under any inertial frame. Means if this particle is a photon or light pulse, if you are watching this particle with respect to s dash or with respect to s, we have to measure that the speed of this particular particle will be always constant, and this constant value is a very nice number. This will be 3 into 10 to the power 8 meter per second. So this particular number is going to invariant. Obviously this is speed of light. Physically we know this is nothing but the speed of light. So obviously the Galilean transformation is not very adequate. It is not very adequate. So we have to correct the thing, and then we have to form a new world, and this new world has identified as special theory of relativity. So first we will, hence it is a very new physics. So we have to first discuss the postulates, and then we will discuss the working method, and the working method is mainly defined by Lorentz transformation. So we will just try to derive Lorentz transformation, and we will just try to see whether speed of light is constant under Lorentz transformation or not. So this is our aim for today's class. So let's try to go for what is a special theory of relativity and what is postulates of this special theory of relativity. Obviously, whatever is the postulates, they all are basically outcome of this very popular experiment that is known as Michelson-Morley experiment. Okay, this is very nice experiment in which we can conclude that the speed of light is invariant. So let's go for first postulates of special theory of relativity. So let's go for this. Yahan tak to that was just a revision part of last class. So let me go for straightforward in a postulates of a special theory of relativity. Why we are discussing postulates? Whenever we are going to solve the problem, we should keep our postulates in our mind. We cannot deviate these postulates. They are just a very well verified rules and regulation. Okay, so let's go for postulates of STR. This is all about a special theory of relativity. So these are postulates. So obviously, what should be first postulates? We have to work with inertial frame because we have to correct the Galilean transformation. So Galilean transformation is inertial frame, and so we have to just work with the inertial frame. And the first postulates is nothing but the Galilean transformation postulates. That means there is not any absolute frame. There is not any absolute frame. What is meaning of that? Meaning of that, you cannot say that one particular frame is absolute and all other frame are moving with respect to this. No, nothing. If you have one frame which is moving with respect to another frame, that means another frame is also moving with respect to first frame. Nothing called absolute frame. That means we cannot say, no, this is only my S frame or this is only my S dash frame. No, you cannot say. You cannot define in each and every time this will be my S frame or this will be my S dash frame. It will our convenience that we should define, okay, let me define this is S frame. Then according to my convenience, this will be my S dash frame. Obviously, if first frame is moving with respect to second one, the second one is also moving with respect to first one. This is all about your first postulates, and this will tell you there is nothing called absolute frame. All frames are relative to each other. So this is our first postulates. Now, let's go for second postulates. Second postulates is again derived from the Galilean one, and this is all about law of nature. Law of nature will be invariant under inertial frame. What are law of nature? Different type of law. Suppose you are talking about Newton's law. This is law. The form of law should be always same. Suppose we have collision problem where in one frame we have conservation of momentum. That means if we are watching the same event from the another frame, maybe the value of momentum before collision and value of momentum after collision of a system is going to change. But if there is conservation law, then obviously conservation law should be measured from the another frame. This is all about law of nature, different law of nature. Whatever with the law of nature you are learning, all should be preserved under the inertial frame. This is very nice thing, and obviously this is very trivial for the any inertial frame, and this is also coming from the Galilean one. But the third postulate is addition into Galilean one, and this will be outcome of Michelson-Morley experiment. What is this third postulate? This third postulate is speed of light. Speed of light must be invariant under any inertial frame. So obviously this is observation, and you never deny observation when you are discussing physics. The experiment have to verify it with the beautiful nature of mathematics, beautiful theory. So we have to give justice to Michelson-Morley experiment by our theory. And so why we have keep this thing as a rule of nature. And this rule of nature is nothing but the speed of light, which must be invariant under inertial frame. I will also add one new postulates, and this is 3a. I will just tell about 3b because we have to go into other than Lorentz transformation, something like mass energy equivalent. Then I need this particular information that not any materialistic particle achieve speed of light. Whatever energy you will give to the particle, whatever energy, if it is materialistic, means if it has some mass, means you can touch it, you can throw it, okay, you can hold it. That means it has some mass. If it has some mass, whatever energy you are going to give this particular particle, what will happen? It will never achieve that speed of light. The speed of particle will be always less than the speed of light if it is materialistic particle. In only one particle, which is light particle, is moving with the speed of light. All other particles have velocity which is less than the speed of light. So these are all our postulates. Whenever we are going to apply the theory, we should always keep these postulates in our mind. Suppose any particle which has mass some mass m, and somebody will tell you it has a speed 2c, he is absolutely wrong. It cannot be happen. Never. कभी भी ये possible नहीं हो सकता है. Okay, so this is very important thing. If you have any doubt, then please raise your question. If you have any doubt, raise your question. Anybody? Okay, so this is okay. Great. हाँ, कुछ पूछना है? Okay, so this is all our postulates. On to basis of postulates, obviously, in the Newtonian mechanics or in a classical mechanics, we use Galilean transformation, but this third postulates is not verified under the Galilean transformation. So we need new transformation, and that new transformation is actually Lorentz transformation. So let's go for Lorentz transformation, understanding of Lorentz transformation, formulation of Lorentz transformation, and we will just try to explain how this Lorentz transformation is going to explain this particular third postulates. Okay, so let's go for what should be nature of Lorentz transformation. What should be nature of Lorentz transformation?